About the properties of integers under multiplication. Properties of integers under multiplication is categorized into closure property, commutative property. Click each tab to know more. Closure property defines that if a and b are two integers, a into b is also an integer. In the first statement, minus 9 into minus 8 is equal to 72. It concludes that the product is an integer. It's an integer. In the third statement, 12 into 1 is equal to 12. It concludes that the product is an integer. Therefore, the above table follows closure property under multiplication. Commutative property defines that for any two integers a and b, a into b is equal to b into a. In the first statement, 5 into 2 is equal to 10, and in the second statement, 2 into 5 and the third property under associative property defines that for any three integers a, b, and c, a into b into c is equal to a into b into c. b into c is equal to a into b into c. Same for the second and the third statements as shown in the table. Therefore, the above table follows associative property under multiplication. Distributive property defines for any three integers a, b. In first statement, 1 into 3 plus 2 is equal to 5, and in second statement, 1 into 3 plus 1 into 2 is equal to 5, and it concludes that a into b plus c is equal to a into b plus a into c. Same for second and third statements. Multiplicative identity property defines that for any integer a, 9 into 1 is equal to minus 9, and in the second statement, 1 into minus 9 is equal to minus 9, and it concludes that a into 1 is equal to 1 into a is equal to a. Same for the second property. And multiplication by zero property defines that for any integer a into 0 is equal to 0 into a is equal to 0. In the first statement, minus 9 into 0 is equal to 0, and in the second statement, 0 into minus 9 is equal to 0, and it can. Let us do a lab activity on the properties of integers. The objective of this activity is to state and illustrate the different properties of operations on integers. The materials required for this activity are a few mangoes, apples, and bananas. Let us assume mangoes represent A and apples represent B. The correct numerical values of the mangoes and apples are noted in the given fields. Here, as both LHS and RHS are equal, we observe that the figures are representing commutative. Let us check for the associative property under addition. Let us assume mangoes represent A, apples represent B, and bananas represent C. The correct numerical values of the mangoes and apples and bananas are noted in the given fields. Let us check for the distributive property under multiplication, and mangoes represent C. The correct numerical values of the mangoes and apples are noted in the given fields. Let us check for the additive identity property under addition. Let us assume apples represent A. The correct numerical values of the apples are noted in the given fields. Here, The above observations can be represented in a tabular form as shown. Integers satisfy commutative, associative, distributive, and additive identity properties under multiplication and addition.
Knowledge check. Attempt the following questions to check your understanding.
Here we will learn about the properties of integers under subtraction. Among all the properties, subtraction follows only closure property. Closure property defines for any integers a and b, a minus b is also an integer. In the first statement, 10 minus 9 is equal to 1, and it concludes that a minus b is an integer. Same for the second and the third statements as shown in the table. Therefore, the above table follows closure property under subtraction. Properties of integers under division. Let us see whether the following properties satisfies the integers under division. Click each tab to know closure property is not followed under division. In the first statement, minus 10 by 5 is equal to minus 2. It concludes that it is an integer. In the second statement, when 3 is divided by 6, the obtained result is 1 by 2, which is not an integer. Similarly, the last statement is not an integer. The above table shows that the closure property is not followed under division. Commutative property is not followed under division. In the first statement, minus 10 by 5 is not equal to 5 by minus 10. It concludes that a by b. Division by 0 is also not a property under division. In general, for any integer a by 0 is not defined, but 0 by a is equal to 0 for a not equal to 0. So, we conclude that anything divided by 0 is not defined. And 0 by any number is always 0. Its example is shown on the screen. Any integer divided by 0 is meaningless or undefined, and 0 divided by division by 1, in general, for any integer a by 1 is equal to a. For example, 2 by 1 is always 2, which concludes that a by 1 is equal to a. Similarly, the next two statements conclude the same. The above table shows that if any positive integer or associative property. In general, associative property is not followed under division. Here, in the first example, initially divide 4 with 2. We get 2. Thus 8 by 2 is equal to 4. Similarly, in statement 2, initially divide 8 with 4. We get it as 2. Thus 2 by 2 is equal to 1. Thus we conclude that a by b by c is not equal to a by b by c. Similarly, the next two statements are shown. Let us solve some example problems. A person climbs up 6 stays every second and climbs down 2 stays the next second. Find the number of seconds required to climb 40 stays. Solution. Given number of stays climbed up in 1 second equal to 6 and number of stays climbed down in 1 second equal to 2. Total number of stays are 40. Total number of stays climbed up in 2 seconds is equal to the difference between number of stays integrate. It went plus increase